Now let's start with the topic mass and weight. Okay, first we'll do the mass. What is mass? First we'll do. Before that, I'll give you the example. Suppose you have tennis ball and cricket ball. Okay, suppose you have one tennis ball and one cricket ball, and we'll easily identify which one is heavier and which one is lighter. From these two balls, we can easily identify the object which one is lighter and which one is heavier. And the cricket ball is heavier and tennis is lighter, isn't it? Now another example I'll give you. Suppose one you have stone and one you have feather. In that conditions also we can easily identify which one is lighter and which one is heavier, like the tennis ball and the cricket ball. As compared to tennis ball, cricket ball is heavier than the tennis ball. We all know this thing. Actually, what is this? And this is the mass. Okay, that means with the mass we'll identify the lighter and the heavier object. That is due to the mass. And mass means a quantity that represents the amount of matter present in any body. That means it's a quantity that represents the amount of matter in any body. Clear? That means the amount of matter will identify the object, the lighter object and the heavier object. And we all know mass is represented by small letter m, and its SI unit is kg, and the SI unit of mass is kg. Always will measure the mass in kg. Now the fundamental concept we have about the mass, we have this. That means mass को fundamental concept के छ भन्दा it is scalar quantity. That means it's a scalar quantity which has only the magnitude. यसको के मात्रै हुन्छ? magnitude मात्रै हुन्छ. Clear? यसको के मात्रै हुँदो रहेछ? magnitude मात्रै हुन्छ. And mass चाहिँ के हुन्छ? it has same value. mass को चाहिँ value will be the same all over. That means कुनै पनि प्लेसमा जाऊ तिमी, तर तिम्रो बडीको मास जति छ, तिमी मुनमा जाँदा, अर्थमा जाँदा, आउटसाइड द प्लानेट, that means outside, कहीँ पनि जाँदाखेरि तिम्रो mass will never changed. Clear? Now another thing, mass is measures of inertia. That means mass always depend upon the measures of inertia. हामीले यो भन्दा अगाडि पनि पढेको थियो, इनर्शियामा डिपेन्ड हुन्छ. It is the measures of inertia. That means suppose you have less mass, less will be the inertia. More mass, more will be the inertia. That means it depends upon the inertia. Now with this we'll conclude the mass. That means mass is a quantity that represents the amount of matter present in any body. Now next we'll have weight. That means we all were confused. No, that means mass and weight is same. हामीले कतिले भन्छ नि, that means mass and weight is same भनेर we are confused. But the mass and weight are not same. Mass र weight चाहिँ के हुँदैन कि हैन, same हैन. Mass all over the place same हुन्छ भने that means weight it's different. Okay, first let's understand what is weight. Weight के हो? That means we all know, हामीलाई सबैलाई याद छ, कुनै पनि चीज suppose कुनै पनि चीज हामीले throw गर्दा, drop गर्दा, that will comes down towards the earth. That is due to the attractions. That means due to the attractions of the earth, which we call the force of gravity ले गर्दा attract गर्छ. And that force of attraction is called the weight. The force of attractions लाई नै हामीले के भन्दो रहेछ? weight भन्दो रहेछ. For betterly, the weight is the force applied on the object by earth due to gravity. Clear? त्यसलाई नै हामीले के भन्दो रहेछ? We called it weight. And in order to understand this weight, just according to the second law of motions. And in second law of motions, we all know that force is directly proportional with the mass, and force is also directly proportional with the accelerations. Isn't it? हामीलाई यो कुरा याद छ. And we know that force is equal to mass into accelerations. And now suppose we are writing this in terms of gravity, accelerations due to gravity. Our force will be force F is equal to mass into g. That means acceleration will be represented with small letter z. And we all know that g is the accelerations due to gravity. And we know the value for g also. And the value for g is 9.8 meter per second square. And the value for g is meter per second square. And in order to relate this with the weight, just now we discussed that force of gravity means weight. Just now, no, we discussed that force of gravity नै भनेको चाहिँ weight हो भनेर. And we know that force is represented with F and will represent the weight with W, capital letter W. So we can replace this F, capital letter F with W, because just now we explained that force of gravity means the weight. So in place of capital letter F, we can write down this capital letter F with weight. So in the next steps, we'll get W equals to M into G, where we'll replace this force with W, that is weight, and our equation will be W equals to M into G. And the SI unit of weight is same as that of force. We know the SI unit of force, that is Newton. So SI unit of weight is also Newton. That you have to remember. And we have learned that the value of G is constant at a given place. हामीलाई याद छ, the value of G, acceleration due to gravity, will be constant at a given place. So we can write down W is directly proportional with the mass. It is due to this reason that at a place, given place, we can use the weight of an object as a measure of its mass. That means, and due to this region, weight is directly proportional with the mass. So due to these regions, we can use the weight of an object as a measure of its mass. And the mass of an object remains the same everywhere. Before I told you, before I concluded it, that mass will be same all over. जहाँ पनि mass same हुन्छ, but the weight will not remain the same everywhere. Weight चाहिँ के हुँदैन, same हुँदैन. That means weight will change according to the place. Moon मा अर्कै हुन्छ, earth मा अर्कै हुन्छ. That is the outer space मा अर्कै हुन्छ weight. Weight will different. That means everywhere weight same हुँदैन, but mass will be same everywhere. That is the difference between the mass and the weight. That means we are confused. Mass and weight हामीले same भन्थ्यो, but with this we can conclude it that mass and weight are not same. Clear? Mass र weight के छैन, same छैन. And another important thing what you have to remember, when we'll measure a body mass, हामी body weight गर भन्छ नि, but that is the wrong thing. That is not the weight, that is mass. Body को mass निकाला भन्नु पर्यो. That means हामीले suppose I'm 60 kg means that is not the weight, that is my mass. Clear? अनि weight चाहिँ different हुन्छ different place मा, whereas mass चाहिँ all over के हुन्छ, same. Just now I told you that the weight will be different in different places, isn't it? The weight will change according to the place. And here also will prove it that how the weight is different in different places, that we will do. That means the subtopic 10.4.1, that is weight of an object on the moon, will do. Okay, that means in the different place the weight will be different banana, just now I told you. Okay, that we will prove. And we all know that the weight on the moon, that is due to the force of attractions, that means the gravitational pull of the earth को वेट चाहिँ के को कारणले भएको, that is due to the gravitational pull of the earth. And moon को weight, that means the weight in the moon, that is due to the gravitational pull of moon. And another thing we have to remember, that the mass of the moon is lesser than that of the earth. That means mass moon मा हाम्रो mass कम्ती हुन्छ र earth मा बेसी हुन्छ. Suppose we have I've given you the example. Suppose I have 60 kg weight in the earth. Okay, I'll go towards the moon. Moon ma गयो भने my weight will be decrease. It's घट्छ. That will be approximately 6 हुनु सक्छ, घट्दो रहेछ. Because the mass of the moon को mass चाहिँ is lesser as compared to the mass of the earth. In order to prove this, that the weight of an object on the moon will go back to the gravitation, that means the universal law of gravitations. Okay, from the universal law of gravitations we can derive the weight of an object on the moon. We know the universal law of gravitation, that is F equals to capital letter Z, capital letter M into small letter m divided by R square. This we know. Now here first before that you have to take the table which is given in the screen. There you have given the mass of the earth, mass of the moon, radius of the earth and the radius of the moon. You have given the quantity. Okay, that means you have to remember this thing which is given in the table. Clear? You have given the mass and the radius of the earth and the moon. Clear? Now next, in case of, we'll do first in case of weight in moon. First we'll do in case of, that means the weight in moon. In case of moon we'll do. So here we have to change a little bit. That means in this formula F is equal to capital letter M, small letter m divided by R square. In this we have to do the little bit modifications. In place of force we can write down Wm, weight in moon. Clear? Wm means weight in moon. Now in place of capital letter M we can write down capital letter M, at the downside small letter m, that is the mass of moon. And the R we can write down R small letter m, that is radius of moon. Clear? So we can put this value on this universal law of gravitation. So we'll get Wm is equal to G, that is the gravitational constant, G into m, capital letter M, small letter m into small letter m divided by Rm square. So Wm is equal to G is as it is. Clear? You have to keep it as it is. Now in place of, that means m means the mass of moon. We have to put the value for mass of moon from the table, which is given 7.36 into 10 to the power 22 kg, which is given in the kg. Clear? Into that is small letter m is the mass of the object. We have not given the mass of the object, so keep it as it is, and divided by R square, Rm square. This is the radius of moon, that means radius on moon, which is given in the table. The value is 1.74 into 10 to the power 6 meter. Clear? Thus we got the weight of moon, weight in moon. Clear? Weight of the object in moon, and marked it equation number 1. Now similarly we can take in case of earth also, same thing. In these equations we have to replace F with WE, that is the weight of earth, M with ME, that is the mass of capital letter M with capital letter ME, that is the mass of earth, and R with RE, that is the radius of earth. And here also same thing, for in place of F we have to write down WE is equal to G ME small letter m divided by RE whole square. So here also we have to put the value. G is constant, keep it as it is. So mass of the earth we have given on the table, that is mass of the earth. The value for mass of the earth is 5.98 into 10 to the power 24 kg into mass, that is the mass of the object, keep it as it is small letter m, divided by radius of the earth, that we have 6.37 into 10 to the power 6 meter, and let this as equation number 2. Now in the next step what we have to do, divided equation 1 by equations 2. That means equation 1, that means left hand side you have to divide it, right hand side you have to divide it. So we have left hand side Wm, mass of the moon divided by mass of the earth, equals to first you have to write down the value for mass of the moon. We have G into 7.36 into 10 to the power 22 kg into mass divided by 1.74 into 10 to the power 6 mass divided by, that means now you have to write down the value for weight of the earth, that is capital letter Z into 5.98 into 10 to the power 24 kg into mass divided by 6.37 into 10 to the power 6 meter. Now in the next steps you have to change that divided sign. If you change the divided sign with the multiplication sign, that time the number will reciprocal. Numerator number you have to write down in the denominator and the denominator in the numerator. Likewise I did it, and after conducting this, after simplifying, we'll get the weight of the moon divided by weight of the earth is approximately equal to, that means we'll get this equal to 0.165. This is approximate value is 1 by 6. We'll get weight of the moon divided by weight of the earth is 1 by 6. Now from here we can write down weight of the weight of the object on the moon divided by weight of the object on the earth is equal to 1 by 6 will get. Now we'll find out weight of the object on the moon, because we are finding the weight of the object on the moon. So weight of the object on the moon equals to 1 by 6 into its weights on the earth. After we have concluded with this we have concluded that different mass, that means weight will be changed according to the place.